Yes, it is a great pleasure to be here, especially in such beautiful surroundings. Thank you for the invitation. Thank you also for a wonderful lunch. I know you've all had the same wonderful lunch, so my job now is to keep you awake for the next few minutes. I'll try. I've lived in Praha now for the last 5 years, and most of my work has been with a specialist software testing consultancy called S-Test, which was created by Robert Duncan about 8 years ago. Some of you know Robert. But as you can see, I've been in IT for rather longer than that. Some might almost say for too long. I actually began as a COBOL programmer back in 1974. And then moved through systems design, business analysis, and project leading roles until about 20 years ago, all of these things seemed to come together in testing. And that's what I've been doing ever since. And of course, in that time, I've seen and I've made a lot of mistakes. In fact, if you search the internet for stories of IT disasters, you'll find plenty to choose from. Some of them were very expensive. Some of them were very embarrassing. Maybe not quite so directly expensive, but embarrassment has indirect costs when your image gets damaged and you lose potential customers. And some of them actually killed people. The problems that Toyota in the United States had with their engine management systems between about, say, 4 and 7 years ago are believed to have killed 86 people in car accidents. And that cost Toyota a huge amount of money in fines and in compensation. But you might look at that list and say, well, this is all ancient history. You know, things are much better now. We do everything much better now. I wish I could agree, but unfortunately the facts speak otherwise. We don't seem to be getting better, or if we are, not very quickly. If we just go back to 2013, to about October 2013, when the US government launched its national website for enrollment in their new healthcare program, on the first day, the number of people who were able to register could be counted on the fingers of your 2 hands. It was 6 weeks before that website worked properly. So, we are still facing problems of late delivery, projects going over budget, and projects absolutely full of bugs. We've been doing this for 60 years, ladies and gentlemen, 60 years. Wouldn't you think we're a bit better at it by now? And, well, actually, yes, we can be better. But I don't mean that we should all be better as individual testers. That's not my point. I'm sure we all want to be, I'm sure we all try to be. But most of the disasters that you saw on the previous 2 slides, well, a few of them you could say were caused by bad testing. But in most cases, the root cause went back much further. The root cause went back to poor planning, and I don't just mean test planning, I mean poor project planning and or very poor requirements. And you might say, well, there's not really much we can do about that. We just have to wait until we get the software and see what it's like. But actually, as experienced testers, we can see these problems early. We can see when they're going to happen. We know the signs. So we can use our experience to help project managers and business analysts improve the foundations that they lay for the work we have to do later. And my theme today is, because we can do that, we should do that. So I'm going to present a few ideas as to how we can do that. Firstly, I'd like to start with lateness. I'm sure we're all familiar with the main causes of projects running late. Often it's because the planners are giving in to pressure from customers or from senior managers who want something delivered unrealistically early, and they don't want to say no. Sometimes it's because, and I've seen this, generations of project managers really don't seem to learn from the mistakes of their colleagues or their predecessors. And sometimes it's just the very common natural human disease of optimism. We all want to say yes. We all want to deliver quickly. And so, of course, we try to. Poor change control, sorry, I'm ahead of myself. Poor change control doesn't help either. And poor impact analysis when changes are forced upon us. That's another very common factor. Well, we should help by putting ourselves in a position early on in a project to review the estimates for effort and the schedules for delivery. And we should be involved in the change control system. We should help with the impact analysis because we know better than anybody else what the impact on our testing schedule is going to be if we're allowed to see details of any proposed change. So there are two things that we can do to help at an early stage. Another common factor in projects running late is that acceptance criteria aren't met as quickly as people hoped when they made the schedule. Often that happens because bad bugs aren't found until it's very nearly time to go live. And of course, the later you find defects, well, the more panic there is to fix them, the more chance of a mistake, the more likelihood there is that the fix is actually not going to work properly. So this kind of winds itself up into a nasty spiral. So we must do whatever we can to make sure that the worst defects are found at the earliest possible stage. Not only when we put our test execution schedules together, but also by trying to find the defects and find the sources of defects before they ever get into development. So, one or two little things we can try. When we are looking at estimates and schedules, look for optimism. Look for unreasonable optimism. Now, if we're not using something like work breakdowns or function point analysis, then we may well be using, or the project managers may be using some form of three-point estimate, also often known as wideband Delphi. I don't know why. Hans, can you tell us why a three-point estimate is called wideband Delphi? Hans isn't listening. He'll probably tell you tomorrow. Okay, and one American project management organization has come out with this so-called PERT method of saying what we'll do is we'll get lots of people to make the estimate, and then we'll take the best one, i.e. the smallest one, and the worst one, and 4 times the average, divide it by 6, and that'll be our estimate. Unfortunately, even when people are told not to give us optimistic estimates, they tend to. Try this. Instead of taking 4 times the average estimate, take 4 times the worst estimate. Add that to the best and the worst and divide it by 6. I've done it. It works. It certainly works better than the other ones. Something else, too, which tends to bedevil projects, especially sequential ones, but it can also apply to the later stages of agile ones, to acceptance testing, performance testing, and final regression testing. And that's that project managers don't understand that you can't just run all the tests once. In theory, it looks nice and tidy, doesn't it? If you use the ISTQB fundamental test process as the basis for this, then we just do one thing after the other, get to the end, and that's all very nice. What actually happens, as I'm sure most of you have seen, is it's not quite so neat and tidy. Because we do a bit of testing and we find some bugs. Gosh, that's a surprise, isn't it? Wow. Ooh, we weren't expecting that. And then, of course, we have to get them fixed. And some of our tests are blocked until they have been fixed. And anyway, when we get the first fix release, we've got to do some confirmation and regression testing before we can get back to our planned execution schedule. So we can expect to have quite a few of these test cycles. And any of you like to tell me how many test cycles you would expect to have on, say, a medium-sized sequential development? Hans? Yeah, that's about typical. 3 if you're very lucky. Could well be 5. In fact, if you come on the advanced test management course that I give, we actually tell you how to calculate the number of test cycles that you're likely to have. It can be done if you can estimate the number of defects that you think you'll get on the basis of what previous projects have been like. That's a neat trick. Puts a little bit of science into this, gives you a bit of credibility with the project managers if you can actually produce some numbers to justify this picture and your calculation of how many cycles you'll need. And of course, it can get even worse than that, because it may be that we're just stuck. Whoops, sorry. It can be that we're just stuck waiting for things before we can get on with the next test cycle. But we can help with that too. There's no rule that says testers can't help our colleagues in development. And I really don't like to see testers just throwing bug reports like, John Wayne throwing a hand grenade in an American war movie. I like to see testers actually doing some research into the bugs they find, getting as much information as they can to help the developers pinpoint the cause of the bug quickly. That helps. And it also reinforces good relationships between development and test teams. That's something to encourage. Okay, so why do projects go over budget? Well, of course, being over budget is usually very closely linked to being late. So, the same factors, usually. But I'm going to look at a slightly different aspect of this for the cost problem, which is about when we find the defects and how much it costs if we don't find them until the last minute. You've probably all seen that sort of picture. Quite a lot of studies have been done about the relative costs of finding defects at various stages in the life cycle. The very first study that I'm aware of was done by Barry Boehm in 1979, and that's the red line on the graph. Now, I know there's been quite a lot of controversy about that. There are people who say that Barry Boehm's data don't really support his conclusion that the cost of bugs in production rises so dramatically. The blue line on that chart comes from somebody who did some similar research in Sweden, and you'll see it's not quite so dramatic, but there's still a very big up curve at the end. The blue histograms are the same data as the blue line on the previous one. The red ones are now from a UK company, a client of Grove Consultants. And those data rather support the original Boehm study. So exactly what numbers you put in it doesn't matter. The lesson is clear. The cost of bugs rises the later in the life cycle you find them, and it doesn't just go up gradually, it goes up dramatically. Not quite exponentially perhaps, but still dramatically. So, there's a concept called the cost of quality. Excuse me. And the cost of quality has 4 components. Firstly, the money we spend on trying to prevent defects, actually on trying to prevent mistakes. And that's basically training and process improvement. Then there's the money we spend on finding bugs and fixing them in our internal testing. That's where our testing budget goes. And then there's the OW factor, the cost of fixing the bugs that our customers find. And if we spend a little bit more on prevention, a little bit more on finding and fixing bugs before they get to the customer, we should see a quite dramatic reduction in the amount of money we have to spend and the amount of credibility we lose by fixing the ones that go live. Sorry. Okay, that's easy to say. However, we need to do it. Now, something's just changed. Has somebody just turned this on? Okay. That's interesting. Right, so the trick is to find as many bugs as we can before they actually reach us. Does that sound silly? Well, it's not really. What I'm talking about now is static testing. Instead of waiting until we've got software full of bugs, let's do whatever we can to eradicate the mistakes that cause them. Static testing doesn't wait for us to see a failure when we're running software. Static testing is when we can actually get rid of the mistake, get rid of the fault before it causes the failure. So I'm talking about static analysis of code, and I'm talking about reviews. Not just code reviews, but reviews of all the documents that get produced from the very beginning of the project until we get something to test. So we don't need to wait. And absolutely anything that you can read can be reviewed. If reviews are done well, there should be lots and lots of benefit. All of those things should be possible. Find them early, not so many to find later when it's more expensive. Find them early, the developers don't need to spend so much time fixing things. They can build more things. Their productivity goes up. Testing takes less time and costs less money. You usually end up with software that's easier to maintain, and doing reviews helps that both directly and indirectly. You also get improved communication because people doing reviews tend to talk to each other. And there are some types of bug or fault that you just can't find with dynamic testing. You won't write a test for something that wasn't in the specification. It's very hard to find design defects with dynamic testing because your tests are normally based on the same assumptions that the design was based on. Interface problems can, of course, be found by testing, but you can find them much earlier and much quicker just by comparing the input and the output and seeing if they match up. Code reviews give you code that's much easier and cheaper to maintain. Code reviews show you deviations from standards, and that will also improve the maintainability of your code base. So, if reviews are such a wonderful thing, why don't people do more of them? Because I know an awful lot of organizations that are very resistant to doing reviews. Unfortunately, I know far fewer organizations who really do them often and well. And unfortunately, I have to blame the project managers for this. It usually looks like this. We have a plan, we have an end date. There's an opportunity to do a design review. Should we? But if we do, we might find something wrong. Then we'd have to go and rewrite the design specification, and that's going to take time. The extra work is going to cause us some delay. So, hey, tell you what, let's not do the review. Don't worry, if there are any problems, we'll just fix them as we go along. And that's what happens. You've all seen it. I'm sure you've all seen it. So, lateness and cost, I've talked about. Bugginess. Why do we get so much of it? And I'm not just talking about functional bugs here. I'm talking about the sorts of things that cause some of the embarrassing disasters, which are not about functionality, not even about performance or usability, but just about whether or not the solution was what the customer needed. Very often, bugginess results, of course, as we all know, from not being given enough time for all the sorts of testing that we'd like to do. Or, well, there was enough time when the schedule was written, but then various delays in analysis, design, and development actually meant that we got squeezed. One of the things that I like about Agile is that doesn't happen. That the squeeze tends to happen in sequential projects, the squeeze at the end. But very often, this is down to poor quality requirements and poor quality specifications. Well, testers are really good at reviewing things simply because we have so much experience of seeing bugs and understanding what caused them. So my message is, get yourselves involved in reviews, sell reviews to the organization, and make sure you're part of it. And remember that the effectiveness of reviews improves dramatically if they're based on using good checklists, whether it's for requirements, whether it's for a GUI, whether it's for a database design. Develop some good checklists to help your reviewers, keep them up to date, keep them focused on the items that keep finding lots of bugs, take away the things that don't find bugs, and you will find that your reviews are even more effective. Something else that I think helps enormously with requirements is something called specification by example, which I got very enthusiastic about a few years ago when somebody gave me a book on it, and I've tried it since and found it's very successful. The problem with most requirements is that they're written in natural language. Natural language is ambiguous, as we all know. Even a comma in the wrong place, I don't know whether this would be true in your language, but certainly in English, if you change the position of a comma, you can change the meaning of the entire sentence. If you actually provide concrete, exact examples of the expected behavior, those ambiguities go away. If you look at that example down the bottom, there can't be any doubt about what the expected behavior is. If you're interested in this, and I really do recommend that you at least investigate it, take a look at Goiko Adjic's website there, www.goiko.net. He's written several books. One of them is actually called Specification by Example. Well, as I say, have a look, see what you think. I think it's a great help. So, in conclusion, the things that I'm suggesting. Get involved early, get involved in planning, get involved in change control, get involved in reviews, and if they don't happen, get involved in selling reviews. Because we really do have a lot of great experience to offer all our other colleagues in IT. Experiment with all the best techniques you can get your hands on. Don't be afraid of making mistakes. Some of them might not turn out to be suitable. Others might turn out to be a great help. And get yourself trained. And put that training into practice. I run ISTQB certification courses. I'm always very disappointed when somebody tells me that they're just here to get the certificate on their CV. I want them to take that training back and use it. And finally, persevere. Don't give up. Some of the things I've been suggesting, especially when it comes to asking project managers and business analysts to change the way they work, are not quite what the rest of IT expects to hear from testers. Most of them are used to thinking that testers just sort of stay in their box and keep quiet until they've got some lousy software delivered to test. Well, no, Mrs. Project Manager, no, Mr. Business Analyst, I'm out of my box, I'm staying out of my box, I'm not keeping quiet, I'm making a noise. And I'm going to make that noise early, and I'm going to make that noise often until you take some notice. So my challenge to all of you is Come and make some noise with me. Thank you.